Okay, so yeah, I hope I'm audible to everyone. We'll just wait for another like 2-3 minutes and then we'll continue. Okay. Okay, we have 17 people watching there. Okay. Okay. Okay, so yeah, I hope I'm audible. Okay, sorry for that. Yeah. Okay, yeah, let me have a look. Yeah, okay. Okay. Hello everyone. Yeah. Okay, fine. So yeah, a very good evening to all of you. I Achal Mishra on behalf of the entire DSC UMIT. Welcome you all to the today's insightful orientation event for 30 days of Google Cloud. Now, before starting with the session, let me introduce you all to our guest speaker for today, Mr. Ali Mustafa Sheikh. So basically, Mr. Ali is the Google Certified Educator Level 1 and Level 2. He manages Google Cloud Developers Community Mumbai as a co-organizer. He is also a part of. He is also a software innovator at Intel and a Microsoft Student Learning Ambassador of Beta level. Now he has done 23 plus international certification from Google and another equivalent organizations for trending technologies like Python, machine learning, digital marketing, and Google Cloud. Recognized by Google students for his excellence in communicating with students at a very young age for computer science, he was awarded total of $5,000 cloud credits from Google for his excellent work in machine learning and cloud domain. Inspired by his journey, he was also called to share his experience at TEDx in Mumbai. And now I think if I will continue telling about his list of achievements, it will take me another 20 to 30 minutes more because I have known him. I think since I was in connect with him since last 2 years maybe, and I have been seeing his regular achievements since then. So yeah, without wasting much of our time, I would like to call Mr. Ali in our frame. Yeah.
Hello, Achal. I hope you're doing good. Hello, everyone. Okay. So let me share my screen and let's get started. I guess we have 33 people here. Let's wait for a few moments. Till then, I share my screen and then we'll be all good. Okay, so I hope you are able to hear me. I hope you are able to see my screen as of now. So how's everyone doing? I guess everyone is doing all great in the chats. And I'll be monitoring chat for quite some time now. So I'll be able to see what you guys are typing and will be able to interact with you directly. Okay. Now this is a beginner session, so I'm not expecting you to have good knowledge of cloud. I'm not even expecting you to know how internet works. Okay. So I'm going to explain everything from bottom line and then we'll go and then there's also a hands-on session planned afterwards after this ends, so stay tuned in, don't leave in between. And then afterwards, you will be given a URL where you can go and you can try this everything hands on. And I thank DSC UMIT for inviting me and having this conversation. So let's get started. Uh, a very warm hello, everyone, from my side. If you're from CS background, then pseudo hello, everyone, because that's like, root sign of, saying hello. So my name is Ali Mustafa, and I build human networks, not the computer ones. They're messy, and I don't like them. And they're also, very much time consuming. So human-to-human networks have always amazed me, and how humans interact, and that's why I have helped, bigger communities, build communities across the globe. I'm also a Google certified educator level 1 and level 2, and being part of a lot of programs lately. So I talk a lot, and you will know that by the end of the session. I also like to click selfies, but we are in a digital setting, so we will maybe click a screenshot or something. But yeah, that that is going to happen. So let's get started. Some of my work which I have done till now is highlighted on the screen, but feel free to kind of grab something. And you might already, if you're already following me on LinkedIn or Instagram, you might know most of these things. But if you're new and you don't know me, then this slide might help you to know more about. Let's get started. So my journey with cloud, before I go ahead and discuss about the cloud platforms and Google Cloud very specifically. So I have been one of the founding members of GDG Cloud Mumbai and currently serving as a organizer for a vibrant community of 4,000 plus cloud enthusiasts. We have conducted multiple meetups surrounding to open source technology and whatnot. I'm also part of Microsoft Launch an Ambassador program where we talk about Azure, and I've been preparing lately for a lot of Azure certifications. I was also part of AWS Educate program in our college and have been using AWS for quite a while. So I come with a background of hybrid. You can say I know a lot of cloud platforms and I have worked with them for at least 3 years as of now. So let's get started. So the first question people ask would be, let's focus on the basics. So how does internet work in reality? Can anyone tell me? So let's say you go to www.google.com. What happens in the background? How does that translate? Yeah. So let's say I want to open, google.com in my browser. Okay. So how does it happen? This is C. Okay. My handwriting is not so good. But yeah. What happens next? Once I type this, will I directly go to google.com even if I don't have an internet connectivity? So most probably what would happen is if you type this, first it will check if you have an internet connectivity or not, if you have a data pack or not. And if you do, then what it will do is it will go to the DNS server, okay, translate this name to IP address, and then it will give you the contents of google.com, whatever is there on their server. Now, this is a very simple way of explaining this, but it really is very complex. So let's say you are on your computer and you type something on your computer. Then you have a router in your home, and then your computer is connected to the router, maybe wirelessly, maybe with a wire. And then that router is connected to something bigger, maybe your ISP or internet service provider. And that internet service provider is connected to multiple nodes, and that's how it is connected to across the globe in different parts. Okay, and that's how internet kind of really works. Now if you want something from this side, you just need to know the IP address, or you need to know the DNS name, so that you can get that website on your system right here. Okay, so if you talk about being from a developer perspective, you guys might be making applications, okay, Android application, iOS application, or websites or desktop application, okay. And what you might have observed is whatever you make, right, whatever you write code, okay. So typically you write code, and then what you do is you deploy this code so that people are able to see this, okay. Most of the developers, most of the students, what they do is they do the coding part, okay, and they succeed at it, but they don't do the deployment part. And that's why cloud as a concept, okay, many of them don't know. And at the same time, they don't know, how to take your application to public, to the world. And we will discuss about few pointers there, and then we will move ahead. So remember, whenever you code something, code is only one part. And many of the people are even having the misconception that you know coding is the only job available in the world in terms of CS. Okay, so even if you are a CS guy, a computer science guy, or doing information technology, coding is not the only job. Okay, it is only one miniature part. Okay, and apart from that, there's a lot of different jobs which CS engineers do. Okay, and one of them is cloud. maintaining cloud platforms, maintaining deployments, making sure your cloud platforms is working properly, and whatnot and whatnot and whatnot. So we are going to discuss more about this part in this session. Okay. Now, what is cloud? Okay. Maybe for a granny or, some small startups who are, some big startups who are teaching coding to kids, they say that cloud is in the air. Okay. And granny might be like, cloud now computers can fly or something. Okay. So what is cloud computing? Okay. Now, if you don't get that reference, maybe you should watch some videos. Okay. Yeah. So what is cloud computing? How does it work? And why do we require? Why do you require it? What's the concept? So cloud computing is nothing but someone else's computer. So maybe this is your computer, right? And this is someone else's computer. Okay. What is the difference between your computer and his computer is that you don't your computer is not active 24/7. Okay. Your computer lacks compute power. It doesn't have a compute power. Okay. I mean, it does have compute power, but it is not as scalable as you can go. At the same time, if you want to buy a config, a normal PC might cost you 1 lakh to 2 lakh to 5 lakh rupees. And again, you are not going to utilize the complete system, whenever you are going to work with it. So there are multiple, you can say, restrictions while you're working with your own, single system. But at the same time, if you talk about cloud, it is a system which is active 24/7. Okay. And it serves all this purpose where you don't have to pay upfront amount. It is there in a secured location, monitored 24/7 by security professionals, by, we can say, the top level executives out there, which is hired by Google or Azure, Microsoft or AWS, and they maintain everything for you so that you just ship your code and everything will be taken care of. Okay. So this is the concept which cloud resembles to. Okay. Now many people will ask, why the name cloud computing? Okay. So how did it got the name called as cloud computing? What was the reason behind naming it as cloud computing when there is nothing related to cloud? Okay. So the name originated from a concept where we talk about IoT, right? So IoT is something called as what is the full form of IoT? Can anyone tell me in the comments? Yeah, yeah, Harsh guessed it wrong. Very, very right, Safed Burfi. So what's the full form of IoT? Can anyone tell me? That's a very standard term. I guess you might be knowing it. Yes, Internet of Things, right? So what was happening is when if you talk about Internet of Things, or if you talk about internet in general, okay. So internet in general. So when internet came into existence, like everyone was talking about internet, everyone was kind of connecting to internet and so on. Uh, People started exploring options. They were like, what more can we do with this internet? What more can we do, right? Apart from sending messages, sending mails, what can we do? And at that time, a concept popped up that if I have a bigger machine, okay, and I want to give this machine to anyone in the world, okay, I want to give access to this machine on anyone on the world, anyone who is using internet, okay. And at that moment, I want, there was like, you can say naming concept. So it is a very funny story kind of. So at that moment, they were like, cloud. So what is cloud? Cloud is everywhere. And what are we providing? We are providing compute power. So that's why it was named as cloud computing. Nothing, much into the typical concept of cloud, but yeah, that is why it was named as cloud computing back then. And this all happened not far back. Okay, it's not 1,000 years back or something. It's just 100, 200 years back. And that's how the concept of cloud computing emerged. So you might be wondering, how does this cloud looks like? Okay, is it like a real cloud, or is it like how does it look like? So you can what is this? If people from CS are present here, they might be able to tell me which hardware device is this. Can anyone tell me? Very simple to identify. So this is Raspberry Pi. Okay. And Raspberry Pi, a single Raspberry Pi. People call it as a mini computer as well, but it is a mini computer, right? It has a CPU, it has memory, it has compute power, it has all the things which we require. Okay. Now, once you have one single Raspberry Pi, what you can do is you can connect a display. Okay. What you can do, you can connect a display. You can then connect, you can add SD card that will act as a storage. I guess there is some background noise because of the rain. Just give me a second. I hope the noise is gone now. Not much. So once we have the display and then we have the SD card attached, uh, then you can say that you can use it as a computer, and you can actually write programs and then you can run that programs on the computer. Okay. And as you do that, it becomes very effective and very easy for you to work with this computer or this mini computer. Now, if I want to convert this into a concept called as cloud, okay, or I want to see how can I make a cloud out of this. So what I can do typically is I can stack them up into different layers. And here I don't just have one Raspberry Pi. There are 1, 2, 3, 4, 5 Raspberry Pis, and they all are connected. They all are interconnected to each other, and they all. So my voice is coming, or is it? There's a lot of background noise. Are you able to hear me clearly? Can you please add that in the chat, because I'm hearing a lot of background noise because of the rain. Yeah, anyone? If you're not able to hear me properly, please tell me. Okay, so I'm guessing that you are able to hear me properly without much of a background noise. So this is how you stack them up, and once you stack them up, you can maybe make them available for people to use it, or you can accomplish your own stuff. Okay. Now, let's go to the next level. Okay. Okay. What is this? This is your normal computer. So it'll be like, what does cloud means here? So does this means cloud? Okay, because you told me this is a normal hardware, and then this is what we can refer to cloud. Uh, can you see this as a cloud where you're making them available, a lot of hardware? You can say a high grade hardware, and you are making them available over internet. Okay, is this approach effective? Can we go ahead and do this approach and make our own cloud? Let's say ialicloud.com, something like that. Can I use these systems and make my own cloud computer like this? Will it work? Waiting for your answers. So mostly this will not work. Okay, why? Because whenever you're talking about an efficient method, what we are talking about, we're talking about sorry for this, let me rewrite this. Oops. Yeah. So we are talking about efficient method. Okay. So efficient means we don't want the screen. Okay. We do want, and we don't want the keyboard. Okay. We don't want the keyboard. We don't want the screen. What we want? We want processor. We want hardware. We want RAM, and we want all that resources. We don't want displays. Okay. And that's why it is not going to be an efficient approach. And that's why we need something more efficient. So how does this really looks like in reality? So in reality, you might say that this is my computer, which costs around a lakh, and this is how a data center looks, with which costs around billions and billions of dollars. Okay, and this is a data center of Google, and as you can see, this complete building, okay, has compute resources, and they have small blocks of stack computers, okay, which are used by us, by them, by Google itself, and by everyone else who Google provides service to. And this is really awesome, because this is where everything comes into the place. The security comes into the place. Every other aspect of cloud comes into the place. Let me remove this and let me show you some good stack servers. And this is the image which is leveled by Google. And if you zoom this in, you can see we are seeing something like a Raspberry Pi with multiple stacks. Okay, a full hardened cooling system on top of this, which is cooling these computers while they operate. And even if if let's say this computer, this chipset, is no more working, I cannot say to the customer that, hey man, your chipset is not working and your data is gone. Okay. What I will be able to do is I will be able to replace that with a new chipset very efficiently without losing any data, and that too in real time, without even a 0% of a downtime. So how is all this possible, and how all this happens? And that's the story which we are going to discuss. So, just imagine this is the sheer scale of Google's data center. And this is how Amazon is also going to be hosting a data center, Azure is also going to be hosting a data center, and so on. Let us go ahead. So what are the features of this so-called cloud platforms? Are they efficient? Are they required in the first place? What are the, you can say, why should we use these platforms? The first and a very, you can say, the foremost benefit of this is on-demand service. So what happens, to just explain you, how are you going to, uh, you know, work with application development, or when you are in a company, is that you have an app idea. Okay, so let's say you have an idea of an app, and that app gives user to store their passwords. Okay, store their passwords. Now you want them to take the username and password and store it inside the application. Very simple application. You go, you create an account, you store the ID and the password. Okay. Now you initially estimated that you are only going to require 1,000 users, and this is your estimate that that is the only number of users which are going to be required for who are going to be using this application, and this is what your estimate told you. And you went to a marketplace, you bought some CPUs, you bought some RAMs, and you bought some you can say storage devices, and you assemble them. Okay, and now your system is ready. You deployed your application on your system, exposed it onto the internet. Now what happened was, in reality, you got only 10 customers. Okay, what you got only 10 customers. Now all the system money which you spent on is now a waste, because you are only getting 10 members. Or in a parallel universe, you get 100K users. Okay, and now your hardware is no more sufficient. You need more hardware, and in that case, this is something which is not much of a feasible approach. So what you will do is you will switch to cloud. Why? Because cloud provides you on-demand service. So what will happen with cloud is, you need one CPU, you get one CPU. Okay, you need 100 CPU, you get 100 CPU. On-demand service. Okay, it's like you can say, you are in a wedding, and there is a buffet system. So what happens usually is, I'm a big fan of desserts. So what I'm gonna do is, I'm gonna only take dessert and starters, and not the main course technically. So what is that called as? That is called as an on-demand service. So similarly, you will get an on-demand service. You are like, okay, I want this things, and I will get that things directly using an interface which is very usable. Pay as you go. You don't need to pay anything upfront. You don't even need to commit. You are like, okay, I want 10 CPUs. Once you start using them, you only pay for 10 CPUs. And let's say you took 10 CPUs, but it didn't work out for you. So you can actually stop it right there, and your payment stops. So you don't need to pay for it for a specific time. That is pay as you go model. Availability. Your application, if you are choosing, let's say, Google Cloud Platform, Google Cloud Platform says it gives you a guarantee of 99.99%, saying that this is the availability guarantee from Google side. Anything happens, if the availability drops from this percentage, they will monetarily compensate you, okay, for your loss. So if you're talking about this kind of availability with Google with cloud, with normal handheld system or a normal hardware system which you are building at your home, this might not be quite possible, because there might be a possibility that the rain is coming, so your internet is not working, or there are n number of different possibility at your home which might not be able to fulfill that criteria. But at cloud platforms, what happens is they don't just have data center at one place. They have data center at different places in the world. So even if there is a national calamity at one place and the servers are down, uh, if you are choosing high availability, the servers elsewhere will be up there, and your data will be replicated right here instantly, and it will be still available. So yeah, you can rely on cloud platform in terms of availability. Large network access. Here we talk about you're not just restricted to accessing to telling your employees to go to your office to access the system. Here you can enable them to access the system anywhere in the world, and with the security, with everything in place. So even if they are joining from a system which is not authorized, which is not part of the company, they are still in a secure place. To give you an example, we will discuss about a lot more services which is provided by cloud, and a lot more players who are into this. So you might have heard about AWS or Amazon, Amazon.com, where you buy stuff. Okay. And Amazon's business was like, buy e-com business. Like basically you know Amazon by e-commerce business. But if you're into CS, you should be knowing it by AWS, because that is a bigger business than their e-commerce business. Microsoft Azure is also a key player in the market, with business suite tools available for each customer. Google Cloud Platform being one of the biggest providers of cloud platform. Salesforce is also one in the market. There are many more, like there is IBM. There are a lot more there in the market. But these are the top players, you can say, and you can find them on any given survey, any given website. So let's look at the services they provide in a deep fashion. Okay. So first thing is on-premise. That is something which you're building at home or at office. Okay. So you're buying hardware and you're building that on your office or at your home. And for that, you need to manage everything. Everything will be managed by you totally. Okay. So you will write your applications. You will manage your runtime. Okay. You will manage your middleware, operating system, virtualization, server, storage, networking, and everything. Everything will be managed by you as an individual, or your team as an individual. Then comes infrastructure as a service, or PaaS. And here we talk about most of the things on top of that will be managed by you, but the underlying infrastructural things will be managed by the cloud platform. So the networking part, the storage part, the server part, the virtualization part will be managed by a cloud platform. It might be Google Cloud, it might be AWS, it might be any other cloud platform. But these all services will be managed by the cloud platform. So they will give you something called as raw hardware. What is a raw hardware? You get a hardware which has no OS, okay, which has you can say no application installed, no app installed. You need to install everything. You need to do literally everything out there onto the system. It is like a raw machine. So infrastructure as a service comes to the place. Then comes PaaS, or platform as a service. Now platform as a service provides you with the ability to even manage the operating system, middleware, and runtime, where you just need to worry about your application and your data. Okay. And apart from that, you don't need to worry about anything because this is also managed by the cloud vendor. And everything, literally everything is managed by the cloud vendor apart from your application. So when I talk about PaaS, let me change the color. So when I talk about PaaS, you just kind of write code. Okay. You majorly write code and you give that code to the cloud platform and the cloud platform runs it for you. Okay. And then we come to SaaS or software as a service. And in software as a service, you can see, let me erase everything. So in software as a service, you see that everything is managed by the vendor and you are just using the service. Okay. You are not doing anything else apart from using the service. Can you give me any example of SaaS? Yes. Can you give any example of SaaS? Everyone in the chat, give me some examples of SaaS. Have you been using Gmail? That is an example of SaaS. I've been using Google Drive. That is an example of SaaS. Okay. Any more examples can you give me? Yeah. Perfect, Shivani. Any more examples apart from these examples? Yes. Dropbox, amazing. Yes. Dropbox is also an amazing example. Anything else apart from Dropbox? Yeah. So all these services which you use on a daily basis, okay, most of them are kind of a like a SaaS platform where you are only using software as a service, where you're not invested into how the application works, etc. Code is work and etc. How is it? How the scaling is happening and etc. You're just focusing on using the application. That is what is software as a service. Now, to explain everything to a newbie, let me take an example. Okay. So let me put a white screen and let me do a very quick example. Let's say you are you shifted to a new city. Okay, so this is you. My handwriting is not so good. Sorry, my handwriting and drawing both are not so good. So you are moving in a new city. Okay, you are moving in a new city, and let's say name the city as what would we like to name the city? Can someone tell me in the chat? Yes. What should I name this city? Come on, be quick. Yeah. What should I name this? So I'll wait for the chat to respond this. Tell me the name of the city. Okay, don't tell me your name. Maybe some city name. Mumbai. Mumbai is already there. Tell me some good city name. Mumbai is a good city, by the way. But yeah. Uh, okay, everyone is Mumbai. So let me name it as DSC UMIT. Okay, this is my city name, and I am moving to DSC UMIT with my luggage. So I have bigger of a luggage again, and I'm moving that luggage and everything to DSC UMIT. I come there, and then I take a home in DSC UMIT. Okay, I take a home here, and I'm like, hey, hello everyone, how is everyone doing? Now I need electricity. What I need electricity. And then what else do I need apart from electricity? Can anyone tell me? Apart from electricity, what else? What other things will I need? I will need electricity. I will need water. Okay, and then I will need security. Right? No one should come and kill me at night, so I need security. And these are the basic requirements. Okay, internet also is there, so I will need internet as well. Okay. Now these are the some of my basic requirements which DSU might have to fulfill. Okay. Now, will I, as an individual, okay, uh, start my own electricity station? Okay, will I do that? Will I start my own electricity station? Yeah. Is it quite possible for me to start my own electricity? I'm like, okay, I don't like DSC UMIT guys. So what I'm gonna do is, this city is not so, you can say, good for me. I'm gonna make my own electricity. Is it a good approach or a bad approach? Can you tell me? Will that be a good approach? Manufacturing my own electricity? Not at all, right? It would be stupid because I cannot bring waterfalls there. I cannot bring hydroelectricity there. I can generate a very little electricity with all the resources which I still have. Okay, so that's not gonna kind of work. Now, what about the water? Can I, say that I will make my own water? I will just depend on the rain, and I don't want your USDS UMIT's water supplies. Will that work? It doesn't work, right? Security, yes, to some extent I can say that I will have my own security. Okay, I don't want your security. I will hire big people for my security, and that can still be done. Internet, you will be like, I will make my own internet. Will that work? Hmm. Will that be a good approach to make my own internet? And then be the only guy who is there in my own internet? No, right? It won't work. A big no, right? So as an individual developer, as a very small developer, right, I cannot afford to do all these things. Okay, these all things are not affordable for me. Okay, so what will I do? What do? You pay monthly. Okay, you pay monthly bill. Okay, so what you will do is, you are like, okay, you give me BMC, you give me supply. Okay, you give me water, I'll give you tax. Okay, I will pay water bill. Okay, and I will pay the water bill, I will pay the electricity bill, and you give me the service. And as soon as you are giving me service, I will pay the bills. And the next day I am moving to a new city. Okay, let's name it Mumbai. And if I'm moving to Mumbai, I don't need to worry. Okay, because I was just paying on a monthly basis, so I don't need to worry. I will grab my bag, move to Mumbai, and without any problem. Okay, so this is an approach which an individual cloud developer or a small startup follow. Okay, so if you're a small startup, you will follow this approach, right? You will be like, I will pay monthly bills. That is something which I can do. Okay, and if I don't like your service, what I'm gonna do is, I will shift to a new service provider, and I will switch to a service provider whom I am more comfortable with. Okay, so yeah. Now let's change the scenario. You are DSC UMIT, and you just made a new city. Okay, this is your new city. Can you follow the same model there? Yeah, can you tell me? You have multiple people living here. Okay, and everyone is going to shift their homes here into your city. Can you follow the same approach which that individual guy followed earlier of renting everything? Can you follow the same approach, or what are you going to do? There are multiple people living in this city. So as a city manager, as a governor, as a government there, you cannot rely on billing model, right? You're like, oh man, this is gonna, there are people who are going to come and live into my city. There are people who are going to, use water. There are people who are going to do a number of things. So in that case, going with this model is not feasible for me. Okay. So what I'm gonna do is, I'm gonna bring my own water supply. Okay, I'm gonna bring my own energy harvesting, which will provide electricity to all these people. Okay, and I'm gonna provide all the services which these guys are gonna require, right? And this it totally makes sense. So remember that cloud is like not the only you like it's not something which is the best thing, but yeah, it is as per your use case, right? So if you're a small startup, you would really want to go to cloud because you don't need to pay anything upfront. For making all the system, DSC UMIT is going to pay a lot of money, right? They are going to get a lot of huge bills, but they are going to recover that bills by serving these customers over time. And that's what Google, AWS are doing. What they are doing, they have built a system and now they are serving customers. And once they are serving customers, they are getting the money, and then they are going to be, kind of equating that money in the near future, and then earning profit mostly. So yeah. Now let's discuss some use cases. There is a user, and he wants to deploy WordPress. What is your approach as a cloud engineer? So you are a cloud engineer, okay, and you need to recommend him what he should do, because he says that he needs to deploy a WordPress site, and he's expecting around 1,000 users. That is the number of users who is going to come. What should you recommend him? Should you recommend him setting up his own server, or what will be your recommendation? Which platform? What should he be using? Come on, be right in the chat. Be quick. Yes, I would be like, you can use hosting services. Okay, like for example, you can use Hostinger, you can use HostGator, you can use multiple hosting services which provide WordPress hosting. Okay, so if you are not having much of if you are not having much of a traffic, you are saying that you will only have 1K user, then you can hire a shared platform and you can go for a normal hosting platform, okay, which are there. Now the user says that he has, it might be 1K users or it might be 100K users. Okay. So in that case, you can say that, okay, these hosting providers are not efficient when you're going for this model. So in that case, move to cloud platform. Okay. And then use any cloud platform which you want. And in that case, you can use AWS, GCP, or Azure, and you can get your work done. Okay. Very, very simple. So remember all these services which are there and which we are going to be using as a cloud engineer. Now, there is one term called as CAPEX and OPEX, which is very business related. If you're a business guy, this should very much resemble with you. Okay. CAPEX means capital, OPEX means operational expenses and capital expenses. Okay. And they both play a very major role. So for some examples is like this. Why we use cloud? So these are the points which I really want to discuss about. Okay. And also this one, equipment failures. So all the services you get as a cloud platform very easily. Okay. And as a startup, you don't want to invest in capital, capital funding. And that's why you will go for the OPEX part, where you are spending more money on maintaining your operations and not maintaining your capital. Okay. Not buying stuff which you will not require in the near future. One very interesting part, how does the market works? Let's talk about numbers. So these are all are in $1 billion. Okay. And as you can see, we are in 2020. And currently you can see the value of each platform from left hand side to right hand side and the total value. And as you can see here, the market is $266 billion. Okay, that's the market for today. If you talk about 2022, you can see the market value that is $354 billion. Okay, and that's massive market. Okay, because everyone is moving towards cloud. Okay, now I'll discuss about why people are moving towards cloud, or what is it that cloud provides and others lag behind in major terms. So very good question which people ask me is, why should I learn cloud? Okay, tell me more about this cloud thing. uh, what will IoT do? What will IoT do? IoT will generate data. Okay, it will generate not just data, it will generate big data. Okay, a bunch of data. Industrial revolution, which is happening currently. Okay, with everything going on, everything becoming smart, everything becoming more and more you can say efficient, and coming up with what is happening is more and more data is coming into the place. And with that, you need more compute power. You need to scale applications more. 10 years back, the technology which you were using, you are not using the same technology now. Everything is changing. And, there is only one job which is going to remain forever. And I can bet and I can say that this job is going to remain forever. Okay. And this is the job of cloud engineer. Programming languages might go, might come, but learning and maintaining cloud is going to stay forever. Okay, because of all these revolutions which are coming in a day-to-day life. Okay, and this is always, you will always, people will always require cloud engineers, and they will always want cloud engineers to be there. So remember that very much, that your job is never going to eradicate. Okay, for one instance, I can say that the job of machine learning engineer will go away near soon, but the job of cloud engineer will never go away. Okay, it is an evergreen job, evergreen job. Okay, it will never go away. And I don't say that by, you can say that Ali, you are saying that because you love cloud. No, because I have seen what's happening in Industry Revolution 4.4, autonomous robots, simulation, system integration, Internet of Things, cyber security. Okay, and cloud computing is something which is going to play very major role in all of this. Okay, augmented reality, big data. Okay, where are you going to store this big data? You will need something which is scalable enough. Okay, and then additive manufacturing, and everywhere one thing is common. Okay, that is data plus compute. Okay, data plus compute. Without data and compute, nothing is going to work. And if you are a small player, what you will need is, you will need cloud. Okay, so I hope this makes sense. And that's why I always recommend learning cloud. Okay, and I'm not telling you to learn GCP. I'm not telling you to learn AWS. I'm not telling you to learn Azure. I'm telling you to learn cloud. Okay, what I'm telling you to learn? Cloud. There are many more underlying concepts like virtualization, okay, networking, security, DevOps, Kubernetes, okay, whatnot. There are so many different concepts, and these concepts are never going to change. Okay, they might upgrade to they might upgrade towards different things, and all these cloud platforms, they provide all the services on top of that. So remember that even GCP, AWS, and Azure, they're all providing the services underlying to concepts of cloud. Okay, also they are inventing their own services, but at the same time, the baseline concepts remain the same. So always remember that cloud is something which is going to stay here, and learn cloud. don't learn GCP, AWS, Azure. Okay. What will happen if you learn only one thing? What will happen if you learn only one thing? Tomorrow, if AWS doesn't exist, your job doesn't exist. Okay. Tomorrow, if Google doesn't exist, your job doesn't exist. Okay. Or Azure doesn't exist, your job doesn't exist. So to make sure that you are at a position where you can switch, learn the underlying concept, okay, and not the cloud platform. Yes, you can be an expert in a cloud platform. So, for example, you can become an expert of GCP, you can become an expert of AWS, and you can become an expert of Azure. But remember that, if you are not familiar with the base concept, then you will definitely be, replaced for your job. So many people will be like, Ali, how should I, what does a job look like? So let me show you how does the job look like. And this is my cloud platform. Okay, this is my GCP cloud platform. And here you can see there are a bunch of resources available here. And what I will do is I will go to my, app engine. And here you can see this is where I have deployed some application. And here you can see a very small application which I have deployed here, which takes notebooks or books. It is like a bookshelf, and you can add a book here, and then you can see multiple books. So I'm saying GCP. Uh, let's say Ali GCP E6, or the Ali date will be today. Let's say let's add this year 2020, and then about GCP, and then I can choose any file which I want. Let's say I'm going to choose this file, and then I'll save this. And what's happening at the back end is here you can see this is the whole console where you can see there is a billing happening, and there you can see how much data I have stored, how much is the usage. Usage is 0.00001 GB, right? And I'm only going to be charged for this much amount of money. So here you can see billable is zero. So I'm not getting any price, and price is $0.006 per GB per day. So my database is sorted. I am not paying much amount of money for the database. But if you guys go here and start, adding resources and doing stuff, okay, there is a server error. Oh, so yeah, uh, it will then keep on increasing. Okay, and it will increase to the amount which I'm using, which will scale to the amount which I'm using. Okay, and here you can see services available. So here you can see there is one default service, and I can diagnose this, I can debug this, and I can see this. So as your day-to-day task, what will usually happen is a guy will come with code, okay, and your job as a cloud engineer will be to accept this code and deploy, manage, and scale. Okay, so your team will give you the code, and your job will be to do all this stuff. Okay, and if there is any problem here, any problem here, or any problem here, it is your responsibility as a cloud engineer to have a look at it. Remember that the developer will come after 1 month, and he will bring a new code. He'll be like, this is new code, a new version. Okay. So again, this is your job to again deploy that, manage it, and scale it. So that is your job as a cloud engineer in a company. So here you can see, there is some error detected, and I can definitely see the error, and I can sort it out accordingly. What learning part do I suggest? I will always recommend you guys if you're learning Google Cloud or AWS or any cloud platform, Quick Labs is the best platform available out there. So it will give you a very good background about how it works. And Google has launched something called as skill batches, which will give you real world scenarios and you can work with them. So this is the URL which you can go to and you can get to know about skill badges. And please stay, till the end because you are going to get coupons, okay, for Quick Labs by UMIT guys. So DSC UMIT guys are going to give you that coupons for Quick Labs, which you can go and you can run it for next 30 days. So yes, I'm up for a Q&A session. So if you want to ask any question, please put it in the chat and we will answer that question and then move towards the hands-on session. I'm watching the chat, so please add your questions here so that I can answer them properly. Hello, Ashil, you're live. Yeah. So keep your questions coming so that I can see here and I can answer them.
Yeah, so okay. So that was a great session, and I'm sure that students have got good insights on cloud technology and Google Cloud Platform, which will surely help the students to get started with 30 days of their cloud track. Now, I, on behalf of the entire DSC UMIT, extend a very sincere vote of thanks to our speaker, Mr. Ali, for giving in amazing insights on introducing Google Cloud to students. It was indeed a pleasure, indeed a great pleasure for us to have you today, and thank you so much for giving us your valuable time. And we look forward to having to have you again soon in near future. Now, yeah, so yeah, let's move forward with the questions if we have any, and then we are good to go with start with our next part of the program. Okay, so yeah.
Okay, so there's a question which says that, what are the underlying basics required for cloud? So underlying basics is you need to know, when you're deploying an application, an HTML application, what is required? You require Apache server, right? You require database. You require XYZ factors. So you should know all that concepts, okay, how these work interrelated to each other, and then how can you deploy them? How can you scale them? We are going to use a magic server. What does a magic server stand for? How does this magic server work in reality? And what are the things which happen when there is a request coming towards your IP address? What are the things which happen at the backend? How does it scale? And so many other things. Apart from, how does the networking work? The security part, and so many different, concepts are there. So I would recommend you to start with understanding, how all this works on a very low level, and then get started on a higher level by using cloud platform like Google Cloud Platform. So this is like typically for 30 days of Google Cloud Platform. So we'll learn to use each service of Google Cloud Platform in 30 days. So starting from how does a virtual machine works, to how does an app engine works, how does storage work, and so on and so forth. So you can learn about each service and then you can deploy it accordingly on the GCP platform. Now there is a question which is called as what is 30 days, hashtag 30 days. So I will give that opportunity to answer for Achal. So Achal, can you please explain this? What is 30 days of cloud?
Yeah, so so we have come up with the latest new. Yeah, am I audible?
Yeah, you are audible. Yes.
Um, yeah, I hope I'm okay. Fine. Yeah, I guess I was facing some issue there. Let me just correct it and then I'll come. Okay, fine. So
Okay.
yes. Yeah, I'm audible, right?
Yes, you're audible.
Yeah, okay, fine. So yeah, you will say, yeah, talking about 30 days of cloud. So yeah, we have come up with a new concept. The DSC has come up with a new concept of 30 days of cloud, which we are like every year it happens. So now we are again back with that for this year. What is happening that we will be having different parts here, different tracks here, and we the first track for us is cloud engineering. So yeah, that is what we are covering up right now. So what will be happening that in the combination of these 30 days we will be covering different concepts including cloud engineering, machine learning, and all the different tracks which are available there. And for that we'll be focusing on we'll be more focused towards peer to peer learning. That is what the main that is what is the main motivation behind starting with the 30 days of cloud. So yeah, by completing the quest under the cloud engineering track, you will be able to learn to explore the and deploy different solution elements including infrastructure components and like different things. And yes, by completing the tracks before 31st October, you stand a chance to win like different Google swags like Google t-shirt, laptop bag, and a lot more. So yeah, that is what it is about. Like basically it is not like leaving apart those goodies part, but it is more like focused towards peer to peer learning, where we as students can learn our classmates or our like other students with our knowledge, yeah, by being the facilitators for different tracks. Yeah.
Thank you so much, Ashil. There is also another question. Doesn't a top-bottom approach make more sense? Yes, it does. So if you want to get started today, top-bottom approach is the best way to go. But if you want to go, so it is like two-way, right? If you want to go long, like, if you want to be in the market for a very long time, then bottom-up approach works. But if you want to get started today, you want to work as a cloud engineer after a month or 2 months, then top-bottom approach makes total sense. So let's say if I am more like I just want to focus on my job, and I see that Google Cloud is something which is growing. So what I would do is I would learn Google Cloud platform. I would go there. I would learn the Google Cloud platform, and I will apply for a job, and I will get a job because that is how the market works. But if I want to go long, if I want to go far, right? I want to incorporate that skills. I want to become an expert of cloud. So in that case, a top-bottom approach will not make much more sense, but a bottom-up approach will make a lot of more sense in that case. Okay. I hope this answers your question, Manish. There is also a question called as what are hybrid clouds? So when I talk about hybrid clouds, I mean to say that uh, you are hosting your database on AWS, but you are hosting your compute power on Google Cloud Platform. Okay. So what are you doing is you are interacting with two, three cloud platforms together. Okay. And that's how hybrid cloud comes into place, where you're using two, three cloud platforms at once. So in that case, you can look at a very great tool developed by Google called is Anthos. And that enables you to work with hybrid clouds at pace. So that is really awesome. Please go and have a look there. And that would really be helpful. Okay. So if there are no more questions, I guess we are good. And this is the URL to join for your meet. It is available in the live chat. So you are, more than happy to go there and join and learn with the hands-on technique with DST UMIT. Okay. There is one more question which I would like to take away. There is what set GCP apart
Yeah.
from AWS?
Once
I
again.
would say that GCP is more focused towards artificial intelligence, machine learning, and big data. And Google has made tools on which people are kind of relying and working on in today's scenario. If you talk about TensorFlow, if you talk about Kubernetes, if you talk about MapReduce, there are so many tools which Google has made internally, which is now being used by open source community on a daily basis. And Google is massive, like it has its data center which is internally users, and that's what sets apart um, Google Cloud Platform with AWS. If you ask me personally, I would be like, if you are a beginner, both are same to you. It doesn't really matter to you. But if you are an expert, then it does really matter to you if you want to go to GCP or you want to go to AWS, because they both will have a different suite of services which you're going to use in your day-to-day life. So yeah, that's it. Thank you so much everyone for joining. Please join at this URL hands-on session is live out there. And thank you so much, Ashil, for hosting me for this wonderful evening. And I hope everyone really enjoyed this.
Thank you so much once again, Mr. Lee.
Okay, so we will end the stream. Sakshi, you can spam with the URL again and again so that everyone has joined the meet, and you can get started with your hands-on session. That is infrastructure in the first part. Also, don't forget to connect with me on all these platforms, and you know, share your insights with me. If you're sending a connection request on LinkedIn, please mention that you came from this session so that I can accept it at the earliest. Thank you so much. Bye bye. Have a good day. Sorry,
Bye
have a
bye.
good night. I mean, okay.
Yeah, yeah. Okay, bye bye.